Okay, it gives me a great deal of pleasure to introduce our next speaker, who is Warren Ferber, WF0T. Warren was first licensed in 1996, and he's held virtually every class of license. He was intrigued by the technician license due to its focus on VHF and above allocations, and spent several years chasing states via meteors on 6 meters. Then he saw the light. He was drawn to it in the 1990s when laser pointers first came out. He quickly seized the opportunity and modulated one for a beacon. He's experimented with detectors and optical chips and spent many a night bouncing lasers off building signs and objects and listening for returns on his receiver. Warren and his partner in crime, Rob, KOXL, have developed quite an interesting optical system, and I'll turn it over to Warren to talk about his experiments.
Great, thank you, Barry. It was 1976 is when I started doing ham radio, and it was 40 meters with a dipole, and I was excited to talk halfway across the state. Things have changed, and I'm excited to just get across a lake. So I guess maybe I'm going backwards a little bit. I want to talk about lightwave communication and why, in my opinion, now is the best time to try it. If you haven't tried it, you've thought about it, this is probably the best time to do it. What I've got up here is I've got one of my transmitters is right up here. It's got 12 LEDs in it. And this is the optical rail system that I came up with, which is what the paper is all about that's in the proceedings. Talks about how this is built, it's got the files, where you can get them all, and all of that. So we're going to talk a little bit more about the results that we've been having with our testing. But I want to start with just a little background information. So this all started back in 2015. I was searching DigiKey one late night, and I found these LEDs that had a lot of output luminosity is what they had. They had a lot of output luminosity, and with that, they were about 70 cents if I bought 25 of them. And I thought, well, what do I got to lose? So I bought 25 of them. Turned it into a little beacon, built in a Radio Shack housing. I use a little Digispark AT-Tiny 85. It's a little microchip. It's Arduino compatible. It's just smaller than the Arduino, has less pins, less ports, and it's just simpler to work with. So I got one of those, coded it up, created a 50% duty cycle, and it sends Morse code. But with this, I was able to bounce it off clouds. I've bounced that signal off clouds at 7,000 feet and got my return back. So it's kind of exciting. I thought this is really kind of cool. I'm able to do something neat. It didn't cost very much, and it's really, other than the LEDs, were things I had lying around the house. So it was kind of fun to do, and I presented this at the Aurora conference in the Upper Midwest back in 2015, and a couple people got interested in it, and so I figured, okay, cool, now we can continue on. So in 2016, I figured I better have a transmitter. So what I did is I created this. I call it my garage door transmitter because Axemen, a local surplus store, had a bunch of garage door opener boxes available. And so I stuck a 9-volt battery in it, stuck my little AT-Tiny chip in there, created a 50% duty cycle, and I have a little beacon on there that is just 3 tones going up and down, that's all it does. Or if I flip the switch, I can get a solid tone, which I can plug a key into that receptacle right there, and I can key it on and off. So it's kind of fun. It uses a Radio Shack jumbo red LED. Unfortunately, they're not available. This is actually a really cool LED. Has a 12-degree beam width. So it's a 6-degree half beam width. So it's a pretty tight beam width. And with this little garage door opener transmitter, I've been able to get at least a mile with no lens in front of it. So I'm just using the LED, and I've been able to receive that signal across Lake Calhoun in Minneapolis, so it's a little over a mile across. And so I've been able to do that. So again, I think I'm onto something. Maybe I built a couple of these in the winter time when it's 20 below zero in Minnesota, so nobody wanted to go out and play. So it was just me again. We have a lot of dark in the winter time in Minneapolis, and so it's easy to get outside and play with light. It's just hard to find someone else that wants to stand out in the cold with you. I have to admit, my wife is a really, really sturdy person in that respect. She puts on 6 layers of clothes, 3 jackets, 2 hats, and sits on one side of Lake Calhoun while I go to the other with the receiver and try to get this. So she's one of my partners in crime. In 2017, I found a way to modulate, and this was really simple. It was out of one of the Sims books, taking the 741 op amp, and from there you put a 555 timer on it, and you modulate that, and you get a duty cycle. I chose a 30% duty cycle, and I'll talk about why I got away from 50%. The reason I got away from 50% was I thought, well, 50%, I get X number of milliamps I can put through it, and it's got so much light output. I thought, what if I do a 30% duty cycle? That's a little bit, almost half as much more, that sounds weird, but that's right, half as much more light output from the LED at a 30% duty cycle than if I run the 50% duty cycle. So I came up with the baseball idea. Same thing as the Beacon, it's got 4 LEDs except I can run voice through it. It worked really well until I started looking on an oscilloscope and started mapping out what was going on. And what ended up happening, the 30% duty cycle means that it's on for 30% of the time and the light is off for 70% of the time. And that little 30% window wasn't enough to modulate it with a lot of audio because it clicks off so fast. And so the audio was really low when I did the 30% duty cycle. As soon as I went to, even though it had more light output, it was harder to hear it. And so when I went and I changed the resistors around and got it close enough to a 50% duty cycle, the audio came up where you didn't need an extra amplifier to hear it. And so I just kind of settled in at that point with a 50% duty cycle for all of my experiments going forward. 750 milliwatts of luminous output, so it actually is kind of powerful at that rate. The other thing, it's there's no way, because this is acrylic and it's actually one of those little trophy cases for autographed baseballs. It's a great holder for this, but there's no way to get it onto a tripod where it can be supported really well without, you know, a lot of Velcro straps or gluing it onto something. And so it really just became a paperweight in my room, and people would come over and they'd, you know, come have dinner or visit, and all of a sudden I was like, what's that? Because it's sitting on the coffee table. So I'd tell them the story and they'd leave. It's like, oh, okay, great, gotta go. And one day the cat knocked it off and the end of the baseball happened at that time. So then 2018 came along, and like most people, I decided I needed to have a 3D printer. I had nothing to print, but I thought maybe a 3D printer would be fun. I could start doing things with it. And so while I'm waiting for the 3D printer to arrive from China, it was a kit, so I knew I had to put it together. And I started thinking about what I could do, and I thought, hey, I could mount LEDs in it. And if I had those little metal LED holders, I could go ahead and use that to kind of act as a heat sink, because these LEDs do get warm. And so that's how I ended up with this thing here, this little transmitter here with the 12 LEDs in front. They're in a little metal housing. Again, I got them from Radio Shack, but with Radio Shack gone, you can get them on Amazon, you can get them on eBay. They're just called metal LED holders, so it's not too hard to search for that. And I've got the 555 timer built into there with an audio amplifier, and this was my first viable transmitter. It mounts pretty well. I had it mounted on wood. I also printed out a 50 millimeter depth lens housing. I had these round lenses I picked up from eBay, and they had a 50.8 millimeter focal point. And so I built and I had to do a couple iterations of this to get it to work. But one of the nice things about a 3D printer, my printer prints down to 0.1 millimeter. And so I can come up with any distance I need, so I didn't have to have a way to focus the receiver to get it in the focal point. I just built the housing to the right dimensions, and I was at the focal point. And I mounted it all on a wooden board, and this actually works pretty slick. My first contact with a human being, and not my wife, because I actually talked to somebody who was with Dawn, WATVOI, it was in January. The winds were blowing about 20 miles an hour. Now, it wasn't 20 below zero. It was only about 5 below. But I want to thank Don, and he put on the coat, put on the hat, and stood, I don't know, we were about 2 blocks away, made a contact with me. We played in the snow by pointing the thing on snow banks. We pointed it off houses. We pointed it off trees, pointed it down the block, and a car went by, and it reflected off the car. And, you know, it was kind of cool. But it was the first contact, and then everybody decided to go home because it was really cold outside, because the wind chill was probably about 25 below. But this is really a viable transmitter and a viable receiver. Now, it's only 90 millimeters, so it's not really large, so your capture area is very small. But again, I dragged my wife out. We went to one side of Lake Calhoun, and I put this on and was able to hear it over a mile in distance. So I know that it's viable, and there was more signal strength left in this system. certainly that I could have heard it far enough away if we had an open space in the city that would be longer than a mile. But without having a lake there, there's too many trees and houses in the city, so that was all I could do. But this also intrigued Rob, K0XL, enough to say, I've got to come up with something now too. He's got a transmitter and a receiver. I've got to come up with the same kind of thing. So Rob came up with something a little bit different. Oh, I'm going to get to that in a minute. Sorry, I last minute changed to my thing. And this is what the 3x4 array looks like. So if you would take this and put it a meter away, it's an 11 centimeter by 13 centimeter block of light that comes out. It's skewed a little bit because when I did this, I didn't have the LEDs all in the same, I guess the cathode and the anode weren't all together. So the cathode was on one side for one LED and it was on the other side for the other, and it kind of gave it a little round circle. But there is an obvious square there that hopefully you can see it. You can see it in the presentation that was given out with the, on the little thumb drive. You'll see it a little bit better there. But it's a 11 by 13 centimeter. It comes out to 6 degrees, and that's the beam width of those LEDs. They've got that built-in lens of a 3-degree half beam width, so 6-degree full beam width. So it is a powerful little LED. It works really well, and it was kind of exciting to have it that. So here's the K0XL system. He went with the old-fashioned wood route, and I call it old-fashioned, but it's really a stable platform when you can build it with wood, and it's very solid, and it works really well. I just couldn't work with wood, which is why I came up with a different way of doing it. So he built a triangle. He's got a way here. You can see the springs in the picture, at least the one spring down here, but it allows him to move the receiver in and out to get it to the focal point of the lens. On top of it, his transmitter, instead of messing with the LEDs, he thought, what if I take apart one of those atomic LED flashlights and try to modulate that? And that's what he ended up doing. It's actually a really cool system. I almost like it better than this because you can culminate the lens with this system, which I'll talk about in a minute, and you can get it down to a half a degree beam width on the LED, using the flashlight along with the lens, and by culminating it that way with just a Fresnel page magnifier. So you can get a very narrow beam width with that, which would allow you to get a much longer distance if you can find a half beam width of infrared light. So the problem with infrared light is you can't see it. And so it's much like a radio signal. I know you're there someplace, but I can't see you, and I can't see your light. So Rob's been working mostly with red light because he wants to be able to see what he's been testing with and what he's been doing. He's had only one run-in with someone about the red light flashing who thought there was a problem and they wanted to call the police because over there something's wrong with the house because there's all these lights flashing. And he had to calm them down and say, I'm just doing some testing. With new flashlights, I'm testing out how powerful they are, and that's why it's flashing. So the guy went back into his house. But other than that, we haven't been bothered with any of our testing with visible light either. The single LED by itself with a flashlight with a built-in lens, when you modulate it, has a 10 centimeter square, and you can tell here in the picture, it's pretty square. You can actually see this is, it would be a better picture. You can actually see the wires that connect to the LED, the little bonding wires that they use. You can actually see that in the reflection on a white wall. I think he was doing this off a wood textured wall, so it comes off a little bit blurry. But and that's at 1 meter, so it's a 5.7 degree beam width that is a built-in lens off the flashlight, which is slightly better than each individual LED here. The other thing that where I was doing just straight audio with a 555 timer and an audio amplifier, I had played with the Arduino chips, and I'm still in the process with that and refining that as we go along. He went ahead and programmed the AT-Tiny, the DigiSpark AT-Tiny 85 board, and he created a beacon. And his beacon is just a CW beacon. It rolls 15 words per minute. He also has a tone test on there, and this is a graph of the tone test, and it's kind of innovative, and so we wanted to make sure that everybody kind of knew that this code exists. It's available for download for free. What he did is he created a power test sequence starting at a 50% duty cycle, and then every step he adjusted the duty cycle to bring the duty cycle down by 3 dB. And so you can actually do some link testing with this to understand what your link margin might be. It goes all the way down to minus 21 dB. His calculation was a range multiplier, however far you can hear the minus 21 dB signal, all things being equal, you could hear 11 times further than the 11 times further than your distance. Now, it doesn't take into effect scattering. If it's foggy, if there's trees in the way, obviously that's not going to happen. But it does give you an idea in free space, in open, dry air, you might be able to get 11 times further if you can hear the signal on the minus 21 dB scale. So he's been doing a lot of testing with that. One of the tests, he had an open space. He lives out in the country, so he's got a little more open space than I do in the city. And he was able to determine that just the stock setup, the way he had it, that wooden system with the flashlight sitting on top without a lens, he could go 100 miles. And so it's a pretty simple system just to take and modulate a flashlight and then take a receiver that's not even as large as this and get 100 and be able to hear it for 100 miles. So there's a lot that can be done with that beacon sequencing that he has built in to just kind of understand if you've got open spaces and you can kind of do that kind of testing. So there's the power sequence and the tone testing as part of his beacon. Recently, he's added an audio input for that, so he's not much into voice communication. He doesn't even like to talk to me on the phone. What he wants to do is he wants to use digital. So he wants to try the JT and the FTs, and he's done PSK31. We've done that back and forth in a smaller space because it was winter time, so we didn't go outside for that. But we were able to send PSK31 back and forth. So it does, the audio input on this particular transmitter. It's just an audio input. You can take the output from a computer, plug it in, and go that way. Some of the key components that we're using, the SFH4550 is the high power LED, comes from Osram. They make them for a lot of different things. This is used in the automotive industry. It's also used in medical parts for scanning the parts as they're getting built and going through to make sure why they optically scan them to make sure that things are in the right places and they're getting the right return from depth and things like that. So that's why they use this. So it's right now they're readily available. The price isn't very high. Again, the price, I think this is based on 25, but this is based on 6 months ago, and I know a lot of things coming from China have gone up in price. That might be about 85 cents for per each one if you're buying them in a lot of like 25 or 40. Cree Lexion 3-watt LEDs. This is what we put into the flashlight. We talk about that in the proceedings paper. What that is a direct replacement for the high beam flashlight LED. That is a white LED. We replace it with either a red LED or the infrared LED. And those on eBay go for about $1 a piece. The DigiSpark board, the AT85, it comes with everything you need, voltage controller and everything is built right into that, so you don't have to do any of that yourself. It's about $1.50. The programming that's included with that is why I have the AT25 microcontroller here. I don't like a company building software to tell me that I have to use their product a certain way. I'm a developer at heart. Maybe that's why I feel that way. So what I did is I just took the bare chip and programmed it myself. They have a slight delay every time you change. If you change a mode, there's a delay. If you try to turn it on and off, there's a delay to get it to fire back up again. And I just like to turn something on and have it work. So I've gone with the chip itself. The chips all by themselves are about $1.11 was the last price I saw for them. So they're again relatively cheap. If you want something that's pre-made that you can plug directly into a USB port, the DigiSpark board or one of its clones is really a great idea. I like doing the chip directly. I have a programmer for it and things like that. And I rather pony up a little more money for what I'm getting than having a company tell me how I have to use their software. Microchip op amp, it runs at 5 volts, which is why I kind of paired them together in my latest iteration of a audio transmitter. They go for about $1.50 a piece. You can also use the LM833, the LM358. I mean, there's a lot of really cheap op amp chips out there that run on different voltages. Matter of fact, the one I've got in here is the LM358. I think I picked that up for like 49 cents. So I mean, there's really cheaper options out there. Page magnifiers, it's just a full-size sheet page magnifier that we're using. Online, you can find them down to $5. If you go to a store, they're usually right around $10. The less flimsy, so they make some really heavy-duty ones. Those are better than the flimsy ones, because the flimsy ones you have to kind of support more, and they kind of wiggle in the wind. And then the BPW34 silicon pin diode detector. This is kind of the heart of the system. Again, it's about $1 a piece. You can get them in a higher lot, and you can get them a little bit cheaper, but if you're only looking for 5, they don't have a lot that small. So, you know, it's about $5 just to have some to experiment with. They also make one with a daylight filter built in. It does not block sunlight. It does have some impact on regular street lights and things like that. So it's called a daylight filter, but the biggest generator of our daylight, it doesn't have any impact on that because there's so much daylight when the sun's out. The difference in the sensors, the silicone diode is kind of focused. The sweet spot for that is 850 nanometers. It is an infrared sensor. However, it is about 67% efficient when you look at red light, visible red light. Most of the LEDs for visible red light are around 630. I've seen some go up to 650 and then down to 610. So that's usually the red light spectrum. The LED itself peaks at 860, but the standards for that LED are between 850 and 870 nanometers. So I figure that that's close enough to have that fit into it. So now I'm going to talk about 2019. So 2019, I had the 3D printer. I started printing up parts like this, and I was looking for a more stable system. And I wanted something that would be that could be in the wind. I could point it up and down and not have to worry about anything. And I was looking for inspiration, and I was going to go take some photographs. I also do a little bit of photography, and I've got a large format camera at home. And I looked at it, and it immediately hit me that the way the large format camera is built, it has adjustments for your front lens and for your lens board in the back. You can tilt them, you can turn them. There's 3-axis. There's even some of them. There's even more than that. And I thought there's got to be a way to build that for a light receiver and a light transmitter. So this is what I ended up coming up with. It's a full-page lens magnifier on the front in a regular picture frame. I got the picture frame from Michaels. It's one of those picture frame kits, so you can make it for any size lens that you may have. We use I just have a mount that's built into a little lens holder. That's all in the presentation in the proceedings. Tripod mount is kind of the basic model to hold most of the parts on. There's a tripod mount below the 3-axis holder. This is Rob's design for his 3-axis holder. I've gone a little bit simpler and came up with a design that is adjustable for any size box you may want to put a receiver in, up to like 5 1/4 inches. Where this is specifically made for one box that Hammond Manufacturing no longer imports into the United States. So there's about a 6-week lag time to get them. So that's one of the reasons I went with a multi-sized lens holder. But this is stable. It holds up really well. I've got 2 different tripods. This is actually my large format camera tripod. And it goes up to about 75-degree angle, and everything stays in place. And the dot that I can see from my test lights points right on the sensor, even at a 75-degree angle. So there's very little wiggle in it. Partially that's due to how the settings I use on my 3D printer. I printed about 65 or 80% fill, so they're pretty thick parts. Some of the parts I printed 20 because they don't need to be that solid. So we've done a lot of experimenting outside with this, and it's been kind of fun. Sartell is where Rob lives, and they have a big old water tower on top of a hill. The furthest we've been able to communicate through that water tower has been 4 kilometers. So it's even though he's out in the country, there are an enormous amount of trees, and this is on a hill, but it's surrounded, you can see, by trees. So we had to go to a golf course. He just happens to know the owner of the golf course, so we can get on after hours without getting chased away by the sheriff. The other thing that was surprising, we pointed a 10 by 10 foot red spot on the city's water tower, and not one sheriff deputy showed up. I was a little surprised. But in their defense, the winds were blowing at 20 miles an hour, and it was about 10 degrees outside. So when we were doing these tests, so they probably didn't want to have to get out of the car. We learned a lot about these tests. It was really neat to have the red light on there. It's obviously really easy to find. I used this red dot on the top of the water tower to focus my receiving system so I could get the red dot right on my sensor. And it actually was so bright at that point, it desensed the sensor, so all it was just, it wasn't even a buzz, it was just a hum. When I pointed it away from the red, from there, and got it down to where Rob's light was pointing, I could hear Rob's music that he was playing as kind of a beacon, because I play music as a beacon, so he thought he had to play music as well, which I appreciated, because it was bluegrass, it was pretty good. So I got my system all set up and got everything pointed, and I got I turned on my my transmitter. At this point, I was just using this transmitter. I put that on, and as I hit it off some trees, so I got a signal return. So I was getting an idea where it was, and I walked it up to the water tower, and I got it to the top of the water tower, and then I walked it down to his red light, and we discovered something that we never thought about in any of our testing. Was if you use something to reflect the light on, and you already have a light signal on it, and put another light signal over the top, you're not going to hear it. We kind of blasted each other's signal out. So when I actually made it all the way on his light signal, infrared light, because it has a little more luminosity and it goes through the air better than red light, and the sensor is much more sensitive at infrared light, I was able to hear my signal, he was able to hear my signal, but we couldn't hear his signal anymore because I completely blocked it out. And so what I ended up doing was I ended up moving mine to the side. So he moved his receiver where I was on the side of the water tower. I kept mine on his, and we could actually hear each other's music without interruption. I couldn't hear mine, he couldn't hear his. But he could hear mine, and I could hear his. So it was kind of a great test that we did. But at that point, we were both too cold to continue, so we kind of just packed it up. We satisfied what we wanted to do and decided it was time to go. So this is a little what I was talking about. This is the transmittance in percentage. Here, this is roughly 850. And 850 is about 90-some% through the air. So just particles in the air are going to scatter it, and I'll talk about what the scattering does in just a moment. But at about 630, it goes to about 75%. There's that dip at 690. I haven't found it, and it's a very narrow dip. And I'm the person that did this and made it available, and he's got a paper about what he was doing with his experiment. It's all on Wikipedia, and he's made this available for sharing, which is really great of him to do that. But I want to find a signal. I'm going to have to find an LED that's really, really, really close to 694 nanometers, because I want to know what that dip is and why there's such a dramatic dip at that. But so far I haven't been able to find an LED with close enough to that frequency where I'm able to hear that dip. The horizon becomes a big thing as well. How far away is the horizon? This is a little graph. It's in the presentation that you got on the thumb drive. You can also get to the website. I've put that on here. It's somewhere, it's probably in my paper. Sorry about that. It's one of the resources. But you can go and you can see that if you are 10 feet above the ground, you can see about 6 miles away from 10 feet above the ground. And so the higher you can go around the surrounding area, the further you can see. Again, in Minnesota, the only place where we can get up to a point that's very high where we can see far away is Lake Superior, up by Duluth. And there's a couple of great overlooks that Rob and I just have to get our schedule planned. So we're hopefully yet this fall, before it starts snowing, be able to get up there and do a test on one of the higher peaks that overlook a lot of Lake Superior that goes into Wisconsin. And we can probably get about 60 miles, because that's the view from how far between the height and where the other landmass is. So we're going to be, hopefully, fingers crossed, and no early snowfall. We'll be able to get up there sometime yet this fall and do that check. So one of the other things that is really kind of fun to do is cloud bounce. We measure and have started measuring now any new thing we do, we check it against the clouds. Can we hear our signal reflected off the clouds? If we can, we know that we're in a good place. If we can't, we know it's not even worth continuing down that path. We have to refine it a little bit. So we've had a lot of starts and stops with different things. I have especially because in the city, I really can only use clouds to bounce. So if I can't get a signal off the bounce, if I'm trying a new transmitter or whatever it might be, if I don't hear the reflection off the clouds, I have to kind of pass on it and go another path. This is just a view of his transmitter. So this is the transmitter section with the flashlight there, and then this is a receiver system. It looks just like this. He's got a little more on the back end because he's got an amplifier attached to his, and I use a remote amplifier. But this is his main setup, and when he does cloud bounce, he moves his receiver further away to the other side of the house so he doesn't get any just regular scatter returns. So the house is kind of blocking that. I do the same thing. I put my receiver in the front, my transmitters in the back of my 2-story house. And so I don't have any scattering in the way I'm able to receive it directly from the clouds. Finding where the clouds are is a good exercise. Luckily, I live very close to the Minneapolis airport, so I can go to checkwx for weather.com/weather/the 4-character code for Minneapolis airport, and basically I get the cloud altitude around my house, which is pretty nice. So I can tell if it's, in this case, the night I did this, there were a few clouds at 7,000 feet, it was broken at 11, and it was broken at 30,000 feet. Probably not a great night to try cloud bounce. When I've done my testing, I did get to 7,000 feet, but it was solid cover at 7,000 feet, and they were broken at like 17,000 feet, but I couldn't see that because they were solid at 7, and I was able to get a cloud return with my beacon. It's just another good resource. So there's airports usually around, even small private, not private airports, but the small municipal airports even provide weather to these services in a lot of cases. So they'll tell you what the cloud height is, which is kind of nice. G8AGN came up with another graph, what the height of clouds are, what degree do you need to point your optical system to get so many miles. And he's got another graph that is in the appendix on kilometers. So it's kind of a good thing to know. Basically, the higher the clouds, the better. The lower the clouds, you can get down to, I mean, if you've got 500-foot clouds, to go 20 miles, you need to have a half-degree elevation. So you have to have a wide open space. Maybe in Montana or Wyoming you could do that, but you certainly can't do it in Minneapolis. So what's next? Well, we want to increase our distance beyond 10 miles. That's been kind of our goal for the year. We haven't been able to get together on that. I've scoped out a couple of 10-mile spots. I've gone one way 7 miles, and it was very loud still. So we know 10 miles isn't going to be a problem. We want to go even a lot further than that. We want to continue our experiments with cloud bounce and atmospheric scatter. We're not really clear, I mean, kind of clear. We know what happens when you scatter light, but the other parts we don't know about what happens with the particulates, because sometimes signals are really loud when there's no clouds, but there's a lot of dust in the air, and you're getting a reflection off the dust. I have, and I'll report it here, this is the first, I believe, recorded scattering of I found a new phenomenon with scattering, which I was very excited about when it happened. I was camping in August, and I brought my transmitter, I brought the beacon, and I brought my receiving system along with me, and I was bouncing light, bouncing it off trees. There was a fire ranger tower a couple miles away. I bounced it off that. It was very exciting. And then I heard a flock of geese flying over. So I pointed my beacon at them, and as they were approaching me, I received scatter from the geese. So I think I might be the first person in the world to ever bounce a light beam off a flock of geese. There was a little flutter, I'll admit that, but it was pretty good. It was kind of fun too because I was able to track them as they went across the campground, and they were going to a lake, and the campground had a couple of towers that were really high, so they had to go up in altitude. And when they got up in altitude, they stayed there, which allowed me to listen to them for a lot longer time. So it's kind of fun hearing my signal coming back off the flight of geese. And then when they were gone, my signal was gone, which was kind of fun. It was just kind of cool. I want to introduce this optical rail system to more hams, more people that may be interested in it. I've been talking to some scouting troops that may want to try working with this. It's something that they can build and use. You don't need a license to do it. So if you've got a understanding wife or an understanding spouse who doesn't really understand what you do with this hobby, you can kind of do this, and maybe they'll come out and help as long as it's not winter, especially if you're living in someplace warm. We want to learn more about what's possible with light communication. I mean, we know that it's mostly line of sight. People think of light going, one way, line of sight, it doesn't bounce off things. But we've learned it does bounce off things. And you can use those things sometimes to extend your range. In France, they've been bouncing it off mountains for a long time, for many years. And they've had regular schedules with two hams that were far away from each other, bouncing it off the same mountain. Wintertime, the signals were a lot louder because white reflects light, even infrared light, better than green. But certainly you can use green. We've used trees to bounce it off. So there's more out there that we can use, and now we've done geese as well. So there's a lot of things you can bounce light off of. We also want to build a daylight tolerant receiver, just because even in the wintertime, it's warmer when the sun's out. KA7 OEI Clint has a daylight tolerant receiver on his website, so I've built one of those. I haven't had a chance to test it yet and optimize it. I've been working a lot with op amps for the last 5 years, so I feel I'm pretty comfortable making things happen. So I kind of built my own transimpedance amplifier, and so I'm going to test that as well. So there's a lot more to go with this Lightwave work, and we're having a lot of fun. So my sales pitch is I hope you join us. It's really kind of a kick to do this. So I've got about 15 minutes left. I have an appendix. I'm not going to go through it. There's more. It's more. I've got schematics in there and all sorts of stuff. So that's all on the thumb drive. I've got the schematic of my AT25 chip modulator, how that works and how to hook it up, and so that's all in there. But it's no fun to look at a schematic as a presentation. So any questions? Yes.